Today we're going to take a broken tool and see if we can turn it into something useful. Maybe it'll work, maybe it won't. Let's do it. I was going through my tool drawers the other day. I came across a couple old air ratchets that I haven't used forever. This one I bought new. Don't really ever use it. This one I think I got it at an auction. And it is completely worn out. I've taken it apart before, and the vanes in there and the little air motor were completely shot. Can't get parts for it. I don't know the brand. There's no markings anywhere. I'm assuming this is just probably some Harbor Freight thing. But I'm going to want to turn it into something new. And I was thinking, the ratchet head still works. What about if I took it and I made it into a right angle impact driver? So if I took this head and I made it so I could run it off a little cordless impact or something else, just to get into those tight areas. I don't know. Let's find out. Let's take it apart. Let's pull out the guts and turn it into something new. Maybe it'll work. Maybe not. There we go. Now we can see inside. Perfect. So this end is just the pneumatic motor. And just puts air in and it just spins this. Spins this little gear, which actually ties into the back of here, which had these two planetary gears right here, and they were locked in with little pins. And then that went up into here, and there's gear teeth in there. Let's put that there. That's there. And this is held stationary, so it essentially reduces the gear ratio. So this spins super fast and this spins slower. And then this is reverse thread. This little thing right here, yeah, just goes in here and it spins and ratchets. Now it's kind of neat because it doesn't matter which way it spins either. It ratchets the same way unless you change the direction of the ratchet. So what we need to do, my thoughts are, we'll just take this piece right here. If we get this all out. Take this piece right here, attach it in there. All we have to do is attach a, I'm assuming something like, let's just attach like a 3/8 inch coupler, weld it in there. Might have to machine this down a little bit. We can grind it down, but I'll put it in my fancy lathe and we'll make this fit in there. This backside was actually retained by this bearing, and then this bearing just kind of sat in here and could move in and out. So if we can attach this in here, this into here, this lock nut would tie them together, and if we just have a extension welded just sticking out the back, we should be able to attach something just like an impact to there, spin it up, and be able to reach into tight areas and just take them off. Of course, we'll have to add some other things like handles so this doesn't spin around, but let's get to that. This doesn't feel like it's a powdered metal gear. It actually feels like it's a forged metal gear, so it should work out good. Good enough. And we got a pass-through hole right there where we can put some weld. Right in there. And then maybe we'll put some out on this outer edge. No, because that's where the bearing goes. So we have to do it with the bearing in place. So if we put the bearing on first, then we slide that in, and we can weld inside there. I wonder how true. You know, grinders are great, but the lathe, let's see how true this spins. Wow, that spins so true. Guess that's why people use lathes. So now, I guess we can stick this in here. And let me take the, let's see. So there's two things it's wanting to do, and that is twist, obviously, from the force of this. But once it starts torquing down something, it's going to start torquing this the way we want. So we need to also come up with a way to hold this head still. And I came up with the technique of using some old sockets, and so I will weld a socket to there. First I was going to put a whole handle on, but I'm thinking that it'd be nice to have a removable handle, and then you can just use extensions in here and just snap them in, and then you're able to hold it where you want. So you'll have one hand essentially, you know, depending on which way you're going. If you're going in that way, you can just snap in the socket, and so you can hold on to this. That angle on there is almost probably ideal, the angle of that head already, so maybe I'll just weld the socket on just like that. So we got this little coupler ring and this coupler. We'll screw that on. And we can tighten that down. Then this screws into here, and those splines are what these little planetary gears run on that we don't need anymore. So this should slide all the way down into there. And then this housing, those little splines, actually rest on the outside of the bearing, and that's what actually holds that in place, and that works good. Then I made a little shim, a little washer, about the thickness so it sits proud, so this washer will hold it in, and then we can put this washer on. And now we just need to have a nut that screws onto the back side of here to hold everything together, and the housing is. So we're going to cut apart the housing, this little aluminum chunk, and we're going to use that as our nut. But thought we would look inside, show you guys just how this little air motor works. There we go. And there we go. So that's just a bearing on the front, a bearing in the back housing, and this is your rotor, and these things are your vanes. Where's my other vanes? There's one. Are they stuck in there? Yeah. Well, not really. So these are your vanes, and I think they have too much wear side to side. There's too much play in them. So either the housing is worn out or the vane, because the vane actually doesn't look like it's worn out really. But those jump out, or it almost touches on that side. The air inlet's right here. There's a little pin. So the air inlet comes in right here, across the top, fills in this spot right here, pushes that vane around. It exhausts, and while it's exhausting, the air is pushing on the next vane. The next vane pops out and it starts pushing around and just spins it around. It's all greased up. Decided to make a, just took some old inner tube, punched out a little rubber washer just to seal up any grease from getting in this back bearing. I'm going to just slide around there, there, and then this should slide on. It's crazy, but why not, right? Let's go test it out. Let's do it at 50. Let's go big. 50 right away. Yep. 50 foot-pounds. Yep. Ready? No problem. No problem. Let's crank it up to 75. I would stupid hand. It's too much for it, but we can crack it free. I really don't know how much force these internal gears can take. This puts out about 125 foot-pounds, 130 foot-pounds. This thing will do 250. But nope. Oh yeah. You don't even really need the... I mean, I can reach my hand on this. This gives me enough purchase. $60. $60. Let's see. This is my most powerful cordless impact at 55 foot-pounds. Can it do 60? No. Nope. Let's see if the homemade job is the most powerful that I got now. Let's try it on this one. Yep. Nope. Nope. Not tight. So, yeah, about 60 foot-pounds. So it beat the Milwaukee, the homemade thing. What about if we throw a 2-foot extension on it? Ready? Yep. Do we even need that? Can we just... Nope, we need that. Boom. Crazy. Who will win speed-wise, though? Ready? Makita. My fastest ratchet. Ready? Go. Makita still dominates. I don't even know what to call the thing, but I guess I turned junk into less junk. Maybe? Maybe I'll use it, maybe not. It's just a fun little project. And on top of that, I built the noisiest blowgun. So the back side of that, right, Ginger? What do you think of this? Wow, that is noisy. You guys can't hear that, but that just deafens you. I'm going to lose a finger.